Hi, physics. This is Miss Satterley. I'm going to go ahead and help you set up these practice problems. So speed and velocity both have the same equation. We have s equals d over t or v equals d over t. So when you do these, you need to make sure you use the right equation. You have to make sure you have your units so you don't mess that stuff up. So what is the average speed of a car that moves 390 meters in 29 seconds? So you have to ask yourself, what am I looking for? Well, I'm looking for speed, which means equals d over t is your equation. This is a very straightforward problem. Distance is always in meters. So we have 390 meters. I'm going to highlight it so it stands out. And then our time is 29 seconds. Remember, always pay attention to sig figs. So this has 2 sig figs, this has 2, so your answer also will have 2. Don't forget that when you have average speed or velocity, your units will be meters per second. Next one. A woman drove 560 kilometers from Los Angeles to San Francisco in 8 hours. What was her average speed for the trip? Again, we're using the same equation. S equals d over t. This is another one that's going to be just plug in the numbers. Your speed and velocity is not always just going to be meters per second, but it's going to be some distance over some amount of time. So in this case, your units are going to be kilometers per hour. Sorry about that. Don't do number 3. Okay, number 4. The stations at 2 ends of a subway line are 6,500 meters apart. So let's go ahead and highlight that. The meters will be our distance. How long does it take for a train to make a round trip between these stations if it travels with an average speed of 8 meters per second? Okay, so we have a distance and we have a speed. Now, I want to notice something, or I want to point something out here. Stations that at 2 ends of the subway line are 6,500 meters apart. This is not your distance, and the reason for that is there's a key word. How long does it take a train to make a round trip? A round trip is going to be that distance twice. So that is what your D is going to be, adding those two together. You have your velocity, which is 8.0 meters per second, so you would just plug in your equation. Whenever you rearrange your equation, V equals D over T, in order to solve for T, your equation is D over V. So that's your distance, and your equation is T equals D over V. Number 5. 2 students travel from school to their jobs at the bowling alley, which is 2.5 kilometers away. One student rides a scooter at 9.0 meters per second, and the other student rides a bike at 12 miles per hour. Who arrives at the bowling alley first, and how long was each person's trip? There are several things you need to do here. So we have D equals 2.5. I am going to change this value to meters. There are 1,000 meters in 1 kilometer. So you take 2.5 times 1,000. So you have 2,500 meters. One student rides a scooter at 9.0 meters per second. You don't have to do anything to that because he already has meters. But your other value, 12 miles per hour, you're going to have to do converting there. I'm going to give you the information that you need to convert these. 1 mile equals 16.334. We're going to leave it at 1609 meters. We also need to convert hours, and that is 1 hour equals 3,600 seconds. So I'm going to set this up. You're going to have to do conversion factors. So you're going to start with 12 miles over 1 hour. And then you convert multiply. So it's our conversion factors. We're going to have to do 2 conversion factors in order to get meters per second. So we have to do these separately. I'm going to go ahead and do the miles first. So I want miles to cancel out, which means I'm going to use this right here, except I want meters on top. So I'm going to put 1609 meters over 1 mile. But I also need to get rid of my hours because I want seconds. So I want 1 hour on top over 1 hour over 3,600 seconds. So when you do a conversion factor, you're going to cancel out miles are going to cancel out, and hours are going to cancel out. So you will be left with meters per second. So you would multiply that out, and that would be how many your meters per second for that part. So this is a 2-part problem. So 2-part problem. And then compare your 2 times that you'll get to see who got there faster. The one you have to convert, the 12 miles per hour, you have to convert to meters per second, but the 9.0 meters per second, you don't have to convert. So again, that's a 2-part problem. And then compare your times to figure out who arrived first. Number 6, sorry. A dolphin can swim 1.85 kilometers per hour. How far does the dolphin travel after 0.75 hours? Express the answer in meters. So what you'll do is your equation, how far does it travel in meters? So distance is our equation. So D equals VT. So that's your equation for that. Your velocity right here. You have your time right here. So you just plug that in. What you'll have to do is after you get your answer, you're going to convert your answer into meters. So you're going to convert from kilometers to meters. And that is, again, 1 kilometer equals 1,000 meters. That's number 6. Number 7. A trucker drives with an average velocity of 27 meters per second towards the east on a perfectly straight highway. Let's highlight this. What will the trucker's displacement be after 3.60 hours? Okay, we have a problem where our units are not the same. So the first thing you need to do is you need to convert hours to seconds. And you're going to use 1 hour equals 3,600 seconds. After that, you can just plug in your numbers to find distance. So again, this is D equals VT. Distance and displacement are related They're both a length between 2 points. One just has the direction, so you'll still use that equation. Number 8. A boy walks 24.0 kilometers in 3.5 hours. Okay, so what we need to do is we have to look and see what are we solving for. We want to find velocity. So we have a distance over time. So V equals D over T. After I get that answer, you need to convert your answer. So convert your answer convert your kilometers to meters and your hours to seconds using 1 kilometer is 1,000 meters and 1 hour is 360 seconds. Now, when you do your equation, just like I showed you up earlier, you have to make sure that your equation is presented properly. So I did meters over miles, but I did seconds over hours because I needed to cancel out the hours. So you need to look at your values. That is why we always keep our values in the problem. Number 9. This is one that I did in class. It's also in the video that I posted. Peregrine falcon is the world's fastest known bird and has been clocked diving downward toward its prey at a constant velocity of 97.2 meters per second. So that's our velocity. Let's highlight that. If the falcon dives straight down from a height of 150 meters, how much time does this give the rabbit below to consider his next move? So this is a straightforward question. You're trying to find time, so T equals D over V. So you have your distance over your velocity, and your units will be seconds. Number 10. A marble accelerates from rest at a constant rate and travels for a total displacement of 44 meters in 20.0 seconds. What is the velocity of the marble? There's some extra information in here that you don't need. Accelerating from rest at a constant rate. That is just there to kind of throw you off. Physics problems will do that, so you have to learn to see the important stuff. So velocity is what we're looking for. Velocity equals D over T, which we have that. We have 44 meters over 20.0 seconds. And that's number 10. Number 11. Number 11 was in the video. I did it in class. So make sure if you haven't watched that video, you do. I will explain it now, though. So Hans stands at the rim of the Grand Canyon and yodels down to the bottom. He hears his yodel echo back from the canyon floor 5.20 seconds later. Assume that the speed of sound is 340.0 meters per second. How deep is the canyon? So you don't have to change the units or anything. We're going to figure out how deep it is in meters. Deep is going to be distance. So D equals velocity times time. So we have our velocity, but our time is wrong. You cannot use 5.20 seconds because this is down and back. And you just want to have the time that goes down. So what you do is you need to divide that by 2 to figure out how long it takes for it to get down to the canyon floor. So instead of using the 5.20 seconds, you're actually going to use 2.60 seconds. So make sure you remember that. The horse racing record for a 150-mile track is shared by 2 horses, Fiddle Isle, who ran the race in 143 seconds, and John Henry, who ran the same race in equal time 10 years later. What were the horses' average speeds in meters per second and miles per hour? Miles per second and miles per hour. So you have a distance. Okay. you have 2. No, you don't. You have 1 time. You have 1 time. What were the horse's average speeds? So speed, again, is velocity. So it is V equals D over T. And you'll plug in your numbers. So distance, 1.50 miles over 143 seconds. But then after that, you need to convert to miles per hour. You don't do anything to your miles. So after you find your answer in miles per second, all you're going to do is convert your seconds to hours using the conversion 1 hour to 3,600 seconds. Remember to set it up where your units will cancel out. 13. For a long time, it was the dream of many runners to break the 4-minute mile. Now quite a few runners have achieved what once seemed an impossible goal. On July 2nd, 1988, Steve Cram of Great Britain ran the mile in 3.81 minutes. During this amazing run, what was Steve Cram's average speed in minutes, miles per minute, and miles per hour? Okay, what we need to do is we have our distance. Our distance is mile, 1 mile. And we have a time, 3.81 minutes. So this is another one where you have to do converting. The first one, you're just going to do your miles per minute, but then you need to convert answer to miles per hour. So after you find your answer, you take that answer and then convert it to miles per hour, where again, you will just simply use your converter or conversion unit 1 hour, 3,600 seconds to do that. It is now 10:29 a.m., but when the bell rings at 10:30 a.m., Suzette will be late to French class for the 3rd time this week. She must get from one side of the school to the other by hurrying down 3 different hallways. She runs down the first hallway, a distance of 35 meters at a speed of 3.5 meters per second. So that is our first hallway. This is a 3-part problem. I did this in class. I did this in the video. So you're going to find the 3 different values and add them together, and it needs to be less than 1 minute. This is a question that I will most definitely have on the quiz, but I will change the values. So you need to know how to do it. Actually, I usually do that for all the questions. I do the same question, but I change the values, so I can see that you understand how to do it. So you're going to do each one of those problems separately and then add them together to see her time. A torpedo fired from a submerged submarine is propelled through the water with a speed of 20 meters per second. So this is important. Let's highlight that. And explodes upon impact with a target 2,000 meters away. If the sound of the impact is heard 101.4 seconds after the torpedo is fired, what is the speed of sound in water? So you're trying to find velocity. This is a 2-part problem. So the first thing we need to do is find our velocity. The first thing we need to do is find the time. Mess that up. So T equals D over V. So you're going to use your 2,000 meters divided by 20 meters per second, and that's going to give you a time value. Now, what you need to do is you're going to take the 101.4 seconds minus your time value, and you're going to have a new time. After that, you're going to find the velocity of the speed of sound in water. So V equals d over t. So your values are going to be, you're going to use your 2,000 meters. That's in the problem. And divide it by the new time that you have found from the first problem. And that'll give you your meters per second or your velocity of sound in water. All right, I have set up all of the problems for you. Again, if you have a question, please let me know. I try to check my messages and email often. If I miss it, you can contact me tomorrow. Please watch this video. This will help you do these problems. If you have any questions, please let me know.